Hello students, next we are going to discuss about the vertical oscillations of a spring. So previous class we are discussing horizontal oscillations of a spring. So that spring is placed in a horizontal, that will be attached with one mass. Okay, so that will be how much you can apply that small disturbance. You will be moving back and forth. That time period t is equal to 2 pi square root of k by m. T is equal to 2 pi square root of m by k. So T is equal to 2 pi square root of m by k. Now next we are going to discuss that spring is placed vertically. So this is the one spring. That spring length is capital L. That spring is capital L. That is having a spring constant K. It will be placed in a vertically. One end is fixed and another one is freely suspended. That length of that spring is capital L. Now you can fix with one mass. That mass is m. So this is the length of mass is capital L. Then so this up to this, the length of spring is capital L and it will be displaced some length L. Okay, so it will be displaced some length small L. So this will be up to an equilibrium position. So when you attach with one mass, it will be moving back and forth, up and down. It will be moving. Okay. So after some time, it will be comes to an equilibrium position. So that equilibrium length displays this small L. Okay. So this will be directly proportional to the L. Okay. So this displacement is small L. So this displacement is directly proportional to the restoring force. So F1 is equal to minus KL. Okay, according to free body diagram. So from free body diagram, FBD, free body diagram, what are the forces are acting? There are two forces are acting. One is the gravitational force. That force is mg. Okay, so plus mg. And another one force. That another one force is F1. So F1 force will be, so now that forces will be acting downward only. So both the forces are acting at the same direction. So F1 plus mg is equal to, any acceleration is there? No. So acceleration is 0. So all that values are 0. Okay. Because it will be on equilibrium position only. So F1 plus mg is equal to 0. F1 plus mg is equal to 0. Now you can apply this F1 by minus KL. You can replace this F1 by minus KL. So minus KL plus mg is equal to 0. Then KL is equal to mg. Minus KL going to left hand right hand side means, so there will be a plus sign. So KL is equal to mg. Then K by m is equal to m by k is equal to L by G. M by m is going this side. So m by k is equal to L by G. You can rearranging this equation. You can get m by k equal to L by G. Okay, you understand? Then next I can apply the one small force, that is the F2 force. Okay, you can apply that one small force, or you can disturb something. So it will be moving some displacement. That displacement is y. It will be after you can disturb that mass. it will be displaced some distance, that is y. Okay, so totally how much distance it will be displaced? So actual length of spring is capital L, and totally how much it will be displaced? Small l plus y. Okay, small l plus y. So this force F2 is directly proportional to L plus y. This force F2 is directly proportional to L plus y. Then F1 is directly proportional to L. Then next what we can do? F1 equal to minus KL. Now you can apply the equal. So F2 is equal to minus K L plus y. Then F2 is equal to minus KL minus KY. Minus KL minus KY. Okay, F2 is equal to minus KL minus KY. Now, next you can apply the free body diagram. So, F1 plus mg is equal to 0. Okay, so from free body diagram, FBD, what are the forces? F2 force is acting downward. Okay, plus F2 plus, and the next one, gravitational force mg is equal to, I can apply the Newton second law ma. So here ma, acceleration is the yes, because it will be displaced some distance from this place to this place. So acceleration is that. So that acceleration m d squared y by dt squared. So ma, you have to define dv by dt, then v is defined as the dy by dt. Yeah, a is also is equal to d squared y by dt squared. Okay, do you understand? So F2 plus mg is equal to m d squared y by dt squared. So totally, what are the forces are acting? The net force acting on that mass is system. Net force acting on the system is, what are the force? Two forces. One is the F2 force and another one is the gravitational force mg. Okay, so F2 is equal to, total force F is equal to m d squared y by dt squared is equal to, F2 is equal to minus KL minus KY and plus mg. From this equation, KL is equal to mg. You can apply this minus KL minus KY mg. You can substitute, you can replace by KL. So plus KL. So minus KL and plus KL cancel. So you can get m d squared y by dt squared is equal to minus ky. Then next m d squared y by dt squared. So already we know that d squared y by dt squared is equal to minus omega squared y is equal to minus ky. So minus minus cancel and y is also cancel. Then omega squared is equal to k by m. Omega squared is equal to k by m. Then omega is equal to square root of k by m. Omega is equal to square root of k by m. Now you can calculate the time period. What is the formula for time period? Time period t is equal to 2 pi by omega. Time period t is equal to 2 pi by omega. Then t is equal to 2 pi divided by square root of k by m. Then t is equal to 2 pi square root of m by k. Then next you can calculate the frequency. So f is equal to 1 by t. The reciprocal of time period is known as the frequency. So f is equal to 1 by t. then F is equal to 1 by 2 pi square root of K by M. F is equal to 1 by 2 pi square root of K by M. Already we discussed the one equation. What is the equation? Mg is equal to KL. Mg is equal to KL. Then K by M. K by K. Here K by M is that. So K by M is equal to G by L. Can substitute that. Then F is equal to 1 by 2 pi square root of G by L. F is equal to 1 by 2 pi square root of G by L. Okay. F is equal to 1 by 2 pi square root of G by L. Or then time period T is equal to 2 pi square root of L by G. T is equal to 2 pi square root of L by G. Okay, you understand? From this equation, T is equal to 2 pi square root of L by G. From this equation, you can square it both sides. So T square is equal to 4 pi square L by G. Then G is equal to 4 pi square L by T square. Or G is equal to 4 pi square L by T square. So this is the way of find out the acceleration due to gravity. So G is equal to 4 pi square L by T square. Okay, do you understand, ma? Okay, thank you.